Hey guys, welcome back to the channel. So let's see where we have left. So we did this one previously. So today we are going to do it's a hard level problem. LeetCode 1755 closest subsequent sum, and we are given an integer array nums and an integer goal. Okay, we have numbers and goal. You want to choose a subsequence of numbers. Subsequence of numbers, okay, subsequence such that the sum of its elements is the closest possible to goal. That is, if the sum of the subsequences elements is sum, then you want to minimize the absolute difference between sum and goal. Okay, fine. So you have to find a number which is a sum of a certain subsequence from this array, and the absolute difference should be fine. Absolute difference return the minimum possible value of absolute, okay, the distance. Okay, so if we choose 5 to the 10 minus 7 is 3 plus 3 6, so the complete sum is equals to 6. So the absolute, choose the whole array as a subsequence with a sum of 6. This is equals to the goal, so the absolute difference is 0. Here the goal is minus 5. To achieve it, we'll add 7 minus 9 and minus 2, which will give minus 4, and the absolute difference is 1. One, two, and 3. Goal is minus 7. So if we take 1, okay, so we should not take anything from here. Okay, so length of the numbers will be between 1 and 40, and numbers will be between, the elements will be between minus 10 to the power of 7 and 10 to the power of minus 7. Sorry, minus 10 to the power of 7 and 10 to the power of 7. And the goal will be between minus 10 to the power of 9 and 10 to the power of 9. Let's see. So from the previous problem, we can do one thing. We have to take the sum of every subsequence and check from it. So to take a subsequence, we 2 to the power of, we might have to do 2 to the power of 40 operations, which is 2 to the power of 40 is 2 to the power of 70 is way too big. Let's see the topics here. Bit manipulation, sorting, bit mask, Well, we are not familiar with bitmask. We are gonna use two pointers and 2 to the power of 40. If we think about taking the complete sum and if the difference is too high, then we should check avoiding one value, either the smallest or the greatest. To the power of 70. 2 power 40 is way too big, right? Let's see the hints. The naive solution is to check all possible subsequences. This works in order of 2 to the power of n. Right, as I said, n is 42 to the power of 40 at in worst case scenarios. Divide the array into two parts of nearly equal sizes. Consider all subsets of one part and make a list of all possible subsets and sort this list. Consider all subsets of one part and make a list of all possible subset sums and sort this list. Consider all subsets of the other part and for each one let its sum equals to x. Consider all subsets of the other part. Okay, and for each one let its sum equals to x. Do bind search to get the nearest possible value to goal. Okay, so let's do total equals to sum of nums. If total is goal, Now let's sort the nums. After sorting, let's implement sub sum subset sum. We will pass a list. Let's add a cumulative value and index count the list if right in the container now to include then if we include index will increment since we included it we'll increment the count to if we exclude the index still increases but the count doesn't the cumulative value also will not change. Right list left list and the center will be let's take it as mid length of so now we reduce the time complexity to 2 to the power of 20 which is significantly smaller than 2 to the power of 40. Let's also check how much is 2 to the power of 20 is. This is also a very huge number but it's comparatively better to and so this is the right half. This is the left half. Cumulative value is 0, index is 0, count is 0, li is left list, default dict of list, so here we didn't use count here at all, we just forgot. Now we'll go through for every every window size from bucket 1. For each distinct value we have to find a target value, where target will be so the sum should be sum is j and target. Goal minus j. Now let's implement binary search. So we'll pass the list and we'll pass a value that is needed to be searched. if only if the central value is greater, then we should avoid all values to its right. So right equals to C, and if then all equals to C plus 1. Since we have sorted it, will we find them in a sorted order, or I guess we don't need to sort this. Instead, let's use it here. Wait a minute. So we have to go through. Also, so one part and make a list of all possible subsums. Consider all subsets of one part and make a list of all possible subsets. Actually, I guess we don't need to separate them out. So let's avoid this count part. Uh, so for every value in the bucket, we'll check for the target in the second bucket. Let's do one thing. Let's only search for I guess you don't need to sort first bucket 2, and we have to find the target value. Now it will give us the index. Let's do one thing instead of if so the index, let the index be t if target is equals to I plus bucket 2 of t. We shall return 0, else we have to record the minimal absolute difference. Answer equals to answer is out of 70. Answer is minimum of answer and absolute difference of I plus bucket of t. Let's do one thing. Let's see if this is working fine. If it works fine, let's discuss the intuition. Oh, I forgot to remove count from here. Destination business not slices. Sorry. and we did a big problem here too. We are not updating the mid position plus or by 2. Now let's see. So it is giving the correct value. Let's just submitting it. If it works fine, then let's start discussing the intuition and wrap this up quickly. Oh, list index out of range. Right. If 0 is the first length of bucket 2, how about now? Let's check now. Oh, so great, it's working fine. So currently we the maximum possible optimization that we can do is this itself. We cannot, like, we are not currently familiar with bit mass corporations. So let's do one thing. Let's write here that will reattempt optimal solution once complete once the completion of bitman once the completion of bit manipulation is done. So I hope you guys understood it. Let me discuss the intuition again. It's not very much different from the previous GPT strategy. Meet the middle. Okay, source half sum of etc. So this is a bit manipulation operation. Bisect left is something we are not familiar with. I think bisect left is binary search, I guess. But the optimization uh, decreases it to 10 folds, which is 2 for 2 300 3000 to 300s. And that's way too big difference. So the intuition is we fetched a total. If the total is equals to the goal, then we are returning it. We are returning it directly. It will reduce one complete 2 to the power of n and the additional binary search operation. So to explain the binary search, we have taken left, right, and center indexes of from a list here, and we are searching for a value. If the center value is greater than the value we are searching for, then we are updating right to C, because since we will do binary search operation on sorted lists and the current index is greater than the value we are searching for, we won't we won't be finding the value to the right of the current index, and same goes for the left index. If the center index is less than the value, then we won't find any value that is greater to its left. So we moved L to C plus 1th position, and if it is found, then we are returning the index itself C. And to break the loop, we have to do we have to hit the condition right. So we are updating it here, which will make the right and left squeeze towards the center, and finally this while loop will break once L is equals to C plus 1. If L and R are same, then it will break. Then we'll be returning L. And for the subset sum, what we are doing is we are having a cumulative value, which is sum of a subsequence, and index is how many blank, I mean how many columns, how many blanks or underlines we are taking, and if we include it, we are adding it up. If you are not including, we are not adding. In that case, that particular blank for the increased index will remain unfilled. In this case, it will be filled, and the filled value is array of index, and we are storing it in the container. So this is that container, and we are filling the second container too. And from the first container, we are searching for all the values. Why did we separate it into two separate buckets? Because uh, 2 to the power of 40 is way bigger than 2 to the power of 40 is way bigger. It is e power 12, which is difference 2 to the power of 20. That's an exponential difference. So the difference is this much, guys. 2 to the power of 20 minus 2. And we are sorting the second bucket because we have to do the binary search on it. and we have a answer. Initialize it to infinity. We are going through every distinct value from first bucket, and we have to search a target value. Actually, we don't even need to do, we don't even need to search the value. If target value is plus, if the absolute difference is greater than answer, else let's let's try submitting it and see how much it will update. 300 and 3600, right? So let's do it. Oh, it increased. Well, this should decrease the entire time by very, that's fine. The test case are very small. So here we are searching for the target. If we find the target, then it is fine. The answer will be 0. Or if the target is a closest value, then the answer won't be 0, and we'll be searching for t minus 1 2, because t and t minus 1 are right and left neighbors for the value we are searching for, which target we are searching for. And finally, we are recording the minimum answer in this entire course of loop, and we are writing the answer here. So that's it, guys. I hope you guys understood. If you don't understood, don't hesitate to ask in the comments. Let me know, and your comments will work as a feedback. I will improve my explanation. And coming to the next thing, so if you like the video, upvote it, share it with your friends, community, and family or someone. If you like the video, also check out the content in the channel. If you like the content too, then hit the subscribe button and enable the bell icon so that you won't miss a video. Uh, so keep pushing hard, keep learning, so that we will end up in a better place. If you find it helpful, let me know in the comments too. Like it will act as an encouragement, and it will push to the other subscribers, not subscribers, other users. So we'll meet you again with another video. Until then, goodbye and take care, guys.